thank you for joining us. I'm just going to kick off with a karakia, and this is about seeking knowledge. So, e te hui, whaia te mataronga kia marama, kia whai take nai, mahi katoa, tu maia, tu kaha, arahau atu, araha mai, tātou I a tātou katoa. And this means, for this gathering, seek knowledge for understanding, have purpose in all that you do, stand tall, be strong, let us show respect for each other, which is very fitting for this type of speaker series. So a very warm welcome to you all, if you're here in person or online. And this is the third in our 70th anniversary year speaker series. And we are very privileged to have Associate Professor Amy Chan with us tonight, who will be presenting on respiratory and AI and asthma. Thank you for coming along tonight. And as mentioned, we have the 70th year celebrations this year, and we are celebrating over $100 million worth of funding towards medical research from Auckland Medical Research Foundation. And for those of you that are donors in the audience, you were the ones that helped make this possible. So a huge thank you from us, a huge thank you from our research community. You have made possible life-changing differences, so big thank you to you. I'd also like to thank our partners that have joined us for our 70th year celebrations, which are the University of Auckland, and we've got Dr. Frank Bloomfield here tonight, and Nina Bowen, also from the University of Auckland. So thank you very much for being here tonight and for your partnership. Auckland University of Technology are also a partner, along with JMI Wealth. And we couldn't be doing what we're doing this year for the celebrations without them also. So thank you very much. So for those of you that don't know me, my name is Sue Brewster, and I'm the Executive Director of Auckland Medical Research Foundation. Lots of people have heard me say that there's 5 of us in the team and we're all executive directors, because that's how good the rest of the team is. And they're all here tonight, and they make the wheels go round on this wagon. So thank you, team, as well. So I know why you're all here, and I am not going to take up any more of your time. Thank you so much, and I'm going to ask Dr. Julie Lim to come forward, please, and do our first introductions for the night.
Thank you, Sue. Well, good evening, everyone. My name's Julie Lim, and I'm a member of the AMRF Medical Committee. And it's my pleasure tonight to introduce our first speaker, Associate Professor Amy Chan. So Amy is the respiratory lead of the Medicines Intelligence Group at the School of Pharmacy, and is soon to take up the role of Head of School. She is a clinical pharmacist by training, with over 15 years of experience in hospital practice. Her research journey began with a desire to better understand asthma, leading to a PhD focused on the use of digital technology in asthma management. Her work at University College London further demonstrated how digital tools can reduce the risk of asthma attacks and enhance the quality of life for those living with asthma. Amy is currently the recipient of the AMRF Senior Research Fellowship and leads a dynamic research group that sits at the intersection of digital technology, big data, and respiratory health. We are delighted to have her with us this evening and very much look forward to hearing about her latest research developments. Please join me in welcoming Amy.
Thank you, Julie, for that very kind introduction. Right, so first of all, I really want to thank you, everybody, for making a time this evening to come and listen to my story and our story. And very much I wanted to share, it's a story that has very much centered around Auckland Medical Research Foundation. We know it's world-class health research. They've talked about how they've empowered researchers like myself and really transformed lives. So I'm going to start with a video that will share a life of a patient that has been influenced by the research that we are doing.
I was having asthma problems. I thought I had it all together, and I didn't. Well, when you're in the corner and you're trying to sit down and you're basically just keeping yourself alive. You're like, all I care about is that as long as I can take my next breath. That's the scariest thing, but you don't know how to communicate that with the people that are sitting in front of you. So it hasn't been a great journey. It's been very tough, and I've pushed myself to the next level where I shouldn't even be standing.
And some of you may recognise that this patient who suffers from asthma is the famous celebrity boxer Mia Motu, and she shared with us her heartbreaking journey and her story and her struggles against asthma. And it's with that backdrop that I have the privilege and honour of bringing you today the story of how we could harness the technologies we have to help people with asthma such as Mia. So tonight in the story, I'm going to structure it easy, 5, 4, 3, 2, 1. Hopefully there's some facts that we can take away. But I'll talk a little bit about 5 reasons why we think asthma matters, 4 facts about asthma attacks that have really informed my journey, 3 discoveries around biomarkers, particularly around the concept of digital markers, 2 key types of digital markers that my particular research has focused on, leading to the DigiPredict study that is funded by Auckland Medical Research Foundation. So I'm going to convince you today and then why asthma matters, and it's not just about breathing. So we know that asthma is affecting somebody somewhere right now, and the rates in the literature vary somewhere between 260 to 330 million people globally that have asthma. And is very much a leading cause of school and work absences, primarily because it is predominantly a disease of childhood, but also we see very severe asthmatics all the way up into adulthood. And actually it causes approximately 450,000 deaths a year, and that is a number that has not really changed since 2006, so our death rate or mortality rate hasn't improved despite available treatment. So back home, if we look at the numbers, if we took the population of New Zealand and just the population with asthma, we know from our research led by our own group that there is an attack happening every 2.5 minutes. There is a death from asthma every 5 days, and this is often underestimated and not talked about as people don't realise the magnitude of asthma and its impact on our population. The cost to society is over $1.2 billion from both direct and indirect costs, and about 14% of our population continue to come through as frequent flyers through our hospital system, being readmitted every month with really uncontrolled asthma. And it doesn't take much. These are just newspaper clippings that I took recently. And you can see that asthma is still very much hitting the headlines in terms of our youth in particular who are dying from unpredictable and sudden asthma attacks. In our research of concern, we also have shown that in the last 10 years or so, even though the prevalence of asthma is relatively stable, about 1 in 8 of our population have asthma, the rates of control have become worse. So the rates of asthma attacks have increased by 1/3 in the last 10 years, and we're not seeing that improving despite available treatments. And really concerningly, asthma attacks are a key source of inequity. If you can see the rates across Māori Pacifica, they're much higher, and the increases are very high across the 10-year period in Māori. You can see here from this particular figure, the highest rates are in Pacifica, followed by Māori, and there is a clear socioeconomic deprivation gradient as well, where the most and highest rates of asthma attacks occur in the most deprived patients. But the greatest increases, however, have been in the least deprived patients. So we know across the board, asthma attacks do affect everybody. In recent work as well, we've also shown there is geographical region and attacks across the motu, across the country. So the red are the hotspots of asthma attacks, which we measured based on oral steroid dispensing data. And the hotter or more red the spots, the greater the number of asthma attacks in that region. And you can see there is really a rural-urban disparity with greater disparity in rural areas, and also a significant distribution effect as well across the North and South Island. But perhaps most importantly, why asthma attacks matter are the patient experiences that we hear. And this is data from interviews that we have done, as well as interviews that other research groups have done. And you can see that having an asthma attack is really, really of concern to a lot of patients. They talk about the fact, they thought they were going to die, and that kids sometimes sit there watching their mum, struggle with breathing, and it really affects, obviously, the experience of both the children and the mother. They talked about airways being blocked by a feeling of like a cement brick. It was really hard, really tight, really gasping for that next breath. And they talked about the effects on sports and hobbies, that they couldn't had to give up their sports and hobbies as a result of their asthma, that it got so bad that they couldn't even walk. And the coughing in particular drains people out. They talk about the coughing really depleting the energy, lasting sometimes for days, up to 10 days. And that a lot of people in particular think that asthma is not taken seriously, which makes it really tough for people with asthma, because people don't know what to look for, and also they don't believe that they have a serious condition until they're literally on the floor. So hopefully I've convinced you that asthma is a really important problem to talk about. And the next part that I want to discuss is around the facts about asthma attacks. So in terms of looking at the history of asthma, so where does asthma come from? It actually comes from, in the Greek times, from the word asian, meaning panting or shortness of breath. And you can see evolution over time from a description of the core asthma symptoms around panting. They also discovered triggers such as pollen back in 1870 as a cause of what they called hay asthma, which has kind of evolved to hay fever. And then in the 1920s to the present, the evolution that has been established, the links between asthma, inflammation, and modern treatments. And over that time, what is core, despite the revolution in treatments, core to this is still that the symptomology, the panting, the shortness of breath, the difficulty in breathing, that has not changed despite the advances in treatment. And also the suddenness of the asthma attacks, that still remains since Hippocrates times. So asthma attacks, we know, is related to things like emergency department visits and hospitalizations, is linked to more days off school and work. But most importantly, asthma attacks are a leading cause of preventable deaths in New Zealand and worldwide. And perhaps one of the most interesting and important facts is that asthma exacerbations are not only an important goal and target for treatment, but it's also associated with progression of asthma. So those people who have asthma attacks, every attack that they have increases the risk of them having the next attack and the following attack, which is why it makes sense that people that we are seeing in our hospital system and in our clinics are often the frequent flyers, because every attack that they have could potentially be leading to more damage to their lungs and a rapid decline in lung function. The good news, though, is that if we look at the timeline of an attack, is that it doesn't happen as suddenly as we think. There is often a trigger that happens, and then the peak attack or exacerbation event, which is where most people focus their energies on, and that's when they present to hospital. But actually, there is this variable onset phase, which can last anything from minutes to days to potentially weeks. We don't know what that speed of onset is, but we know it is variable, and there is a chance perhaps to intervene in this onset phase to abort the entire process of an exacerbation. And perhaps this is where we can save lives by helping signal when a person has an increased risk of an asthma attack. And we also noticed from a very important piece of work done by our colleagues in the UK, which is the UK National Review of Asthma Deaths. So what they found is over 95% of asthma deaths actually occur in adults with known risk factors. So these are people who have known risk factors for attacks. And 85% of deaths don't actually occur suddenly, as we think, as is depicted often in movies, but is actually progressively worsening over days and weeks. So this is one of the key recommendations from their report, which we wanted to act on. The key advice was know your risk of having an asthma attack. And I was like, this is easier said than done. And we could tell our patients, you just need to know when your risk is worsening. But actually, if you look at the evidence, at least half of the people who died did not know about their risk, and they were just being treated for mild forms of asthma or moderate asthma. It's not the severe forms that come to hospital that's under specialist care that we're worried about. It's the mild to moderate people with asthma that may only have symptoms 0 to 1 times a month that are dying from asthma. And in particular, this particular statistic hit home for me from the report that poor recognition of risk of adverse effects was found to be an important modifiable factor in 70% of children and over 80% of young people. They simply just didn't recognize how severe their asthma attack was and how important it was to seek help and intervene. And I think we can all know people how busy lives can get. It's just so easy to adjust. You've got a bit of breathlessness, you want to keep going. Life is busy, you don't want to stop to make a medical appointment, or you might have to wait days before you get to see your GP. And actually that time is lost, and this is where we could intervene to signal earlier to save the lives of these preventable deaths. So this is where I started my journey to action that particular recommendation. What can we do to help identify people at risk using digital biomarkers? So if we take a little journey down into people's airways, so we know asthma is a combination of issues with breathing. There's in the lungs, there's inflammation, and down in the airways. And what we can see is there's increasing mucus and airway inflammation, and airway is tightening over time as the risk of asthma attack increases. But unfortunately, unbeknownst to a lot of people with asthma, you have to reach a particular threshold before we recognize the symptoms are bad enough to act upon. So what we are essentially doing when that happens is we're waiting for the fire alarm. So, as inflammation builds and the symptoms appear, we only react when the symptoms reach a particular threshold, and all the current guidelines and the asthma action plans that we have are symptom guided, and we only act to increase treatment or seek help or see a health professional when symptoms get worse and an attack occurs. But really, the key point is, what if we could see the smoke before the fire happens, very much similar to a fire alarm? And this is where the analogy happens with the work that we've been doing with digital markers. As the inflammation builds, as I saw in the airway, and it's often silent, we could get data insights now that can provide insights into what's happening in the body based on these digital biomarkers. And as the symptoms start to appear, we can actually take preventative action already before they reach the point that the symptoms become so bad that they reach an attack point. And ultimately, we hope that will help change care from reactive to proactive care. So, in summary, the opportunity we're looking at is that because attack risk increases over days to weeks, there's this untapped opportunity to intervene. And what AMRF has allowed me to do is really focus on this point to see, are there digital markers I can detect using everyday technologies, and can we develop a risk alert system using these everyday technologies? So what can we do to sense? Basically, we know we have traditional biomarkers, which I'm sure most of you are familiar with. So things like taking a blood test, a tissue sample, or taking a peak flow or exhaled nitric oxide measurement as a marker of inflammation in the lungs. But the problem with these traditional biomarkers is they're not often accessible. And if you think of the analogy, it's a bit like you can take a photo, which is only a cross-section in time, but we don't know what's happening over time in between those photos. What digital biomarkers allow us is an ongoing continuous video feed. So no longer do we only have snapshots in time of what's happening to people. We can actually have a live video feed to actually understand what the person's risk is and physiologically what is happening. And this is quite interesting. This is just an example from an Apple Watch of a cardiogram. But you can see they look so varied, and there's so much data in each of these cardiograms, like the way someone's sleep looks without alcohol, and then with dinner, alcohol after. Sleep is very much affected, and the patterns look different in someone who's had alcohol. Likewise, we can say there's fitness data, but fitness data looks different in people, who've done regular running episodes as opposed to someone playing continuous sports games such as hockey. And same, all of you who came here in rush hour to come and see us, distress or driving in rush hour compared to going for an interview, for example. The stress is more sustained during a drive in rush hour compared to if you were going just for an interview. And with illness, again, atrial fibrillation looks quite different to atrial flutter. And are these learnings that we're trying to draw on to help develop this particular digital prediction alert for asthma attacks. So talking a little bit about digital markers. So digital biomarkers have been recognised by the FDA formally since around 2022. And the officials have recognised that often people have misused the term digital biomarkers. And now they've actually set on a set definition of what a digital biomarker is. So when we look back at the basics of detecting disease, often we start with patient questionnaires or symptomology. So that's often outcome assessment. So those are COAs, where we focus on consultations or outcome assessments to assess how patients feel using outcomes, using questionnaires. And there are true biomarkers, like the traditional biomarkers I've talked about, so visiting a lab, taking a blood test. And then what we're trying to focus is that in between using a digital health technology, DHT-derived measure. So how can you use technology to capture some of those physiological changes and some of those behavioral changes? So instead of just using questionnaires or taking blood tests or labs, can we use this technology to develop that is developed around us to detect both behavioural and traditional changes. So digital biomarkers, the formal definition from FDA is basically a characteristic or set of characteristics that's been collected from technologies, and it's used as an indicator of changes on or responses to an exposure of intervention or therapeutic interventions. And this is where digital biomarkers really come in from consumer-grade devices. They allow us to collect insights 24/7 into what's happening into people's bodies, so we can provide real-time alerts, forecasts, and personalised results specific for that particular individual. And actually already exists for a number of different conditions. So FDA, I think, approved the first digital marker in clinical trials around 2022 for Parkinson's disease. So it's been used to look at motor activity and looking at tremor based on a wristwatch. It's also been used for things like neurological conditions and metabolic diseases. It's been used in COVID and sleep disorders. But really, what about respiratory or asthma disease? And so this is where we're trying to see, what is the use of digital markers when it comes to helping, shared decision-making, helping to triage patients, for example, helping to monitor the therapies that they're on, and also thinking about when to start or stop treatments, particularly some of the more expensive treatments, such as biologics. When should we be starting these and when should we be stopping them? So Julie, in her kind introduction, mentioned about some of the work I had done at University College London. And this is one of the large Cochrane reviews, many hours of looking through the literature. But we really found that digital technology can play a role in helping manage asthma and potentially halving the risk of asthma attacks. And it is from this Cochrane review that we then moved into this phase of research to see how can we actually harness that particular potential to really help predict asthma attacks. So meet Jay here. He's actually in the audience, one of our team members. But let's take an example. Jay here has particular love of technology, and he's got a range of different types of smart technologies. And this is to show you that these technologies exist. There are smart glasses that already exist that can track eye movements. There's smart shirts and take samples of your sweat and do a physiological evaluation. There's smart watches, which I'm more sure you're all familiar with. There's also smart shoes that look at your cadence, your walking patterns. That's been used in Parkinson's disease. Smart socks also to look at your sweat patterns, your volume. Do electrolyte assessment if you wish for that to happen. There's also things like smart belts, baby controls. I know they've used it to see if they can prevent cot death. There's little anklets that you can give the babies to look at how much movement they have in the cot. And to sense things like respiratory rate. And also things like smart rings as well that also look at the same parameters as smart watches. So these all do exist. They're not something, in sci-fi movies in 2050. They already very much exist nowadays. And so what can these smart technologies collect? Well, physiological parameters, behavioral parameters as well. So it can monitor things like medication use, activity levels, sleep patterns, environmental as well. So by tracking location, we can link directly to environmental data, pollution, air quality. And these are all very important data points when it comes to respiratory disease. And just to contextualize device ownership rates, so year on year, about a third of our population already owns smartwatches. I'm sure many of you in the audience may already have a smartwatch that you're currently wearing, and definitely smartphones. And year on year is one of the greatest and most massive changes year on year. It's growing in its market size about 10% every year. And there's New Zealand, which is roughly the worldwide average. It's roughly ranging, I think the updated stats are more close to about 30% in terms of people who own a smartwatch. So now onto the actual juice. Now, what are these digital markers that we're looking at? So this is the study that we've been doing with AMRF support. So what we've been doing is we've been giving people with asthma in New Zealand, and we've been asking them to monitor their peak flow, to use a smart inhaler, which will track their inhalation patterns and their medication use. They all got free smartwatches, so they were very happy to take part in the study. And they also got a smartphone app to really monitor their symptoms over time. And what we were hoping to do was link it with data from the Ministry of Health and environmental data sets from LAWA/NIWA, Stats New Zealand, to generate this clinical risk score, which will give you an asthma status at a glance and provide insights into a person's asthma attack risk. So what we realized, really it comes down to two types of digital markers. It's either symptom-based or physiological-based markers. So symptom-based markers are things that are driven by symptoms. So we know that cough and wheeze, as coughing goes up, people's inhaler use naturally also goes up, and we can now capture that early on using smart inhaler technology. And you can see as it goes up, the peak flow also goes down. So that's a physiological marker. The other important symptom-based marker is in the last probably around 5 years or so, there's been cough monitoring apps. AI cough monitoring apps that exist. You can look them up on the App Store. There's a couple of different competitors out there, but they mainly use the inbuilt microphone in your phone, and it's trained only to detect cough, which we tell patients it doesn't detect conversations, but it is trained to only detect cough sounds. It can count the number of coughs and also give you an idea of whether they're dry or wet coughs. And in particular for asthma, we were particularly interested in nighttime cough, because we know nighttime cough is a cardinal symptom of worsening asthma. And what we did see here, in the left-hand side, is the cough count over time relative to the date of the attack. So 0 was the date of the attack. And you can see there is an increase in the median number of cough counts leading up to the attack. Or when we looked at a mean cough count, this is what we saw in patients, is that there is an increase about a week, 7 or 8 days before their attack, leading to a peak potentially in the day before they reported the attack to us. And again, you can see here, we looked at the mean cough count over time, and -1 is where it peaks, and 0 was a day where they reported it to us. So we felt that this was quite an interesting marker of worsening asthma, potentially up to 7 to 10 days before the self-reported attack occurred. And again, this shows you basically the confidence interval, but across the sample of, I think there was 140 in this particular sample, you can see there is that pattern in cough leading up, in the days leading up to an attack. There's also rescue inhaler use that I mentioned. So you can see, and this is not my work, in America, they gave people, again, a rescue smart inhaler, and they were able to monitor the number of doses of rescue inhaler use. And you can see it increased again around that 7-day mark leading up to the attack. So now you can see there's a bit of a story with that 7-day mark. And same with physiological measures. So here, this is actually not a digital study and done in the 1990s, but probably one of the most important studies that actually identified these key markers to show that actually before an attack happens, which is on day 0, there is a fall in peak flow and an increase in asthma score. So even back then in the 90s, they were recognizing that asthma attacks, there are markers that happen perhaps in the days leading up to the attack. And we were able to see the same here. So this is an our study sample in DigiPredict. You can see again about that week, there's that drop in the peak flow around the attack period and in a recovery period after. And we also got, using these smart inhaler technologies, we were able to capture things like inhalation parameters, which we weren't able to capture before. This is from a US study, but we saw very similar data that leading up to the attack, there was a drop in inspiratory flow, which was really interesting for us because asthma management has focused a lot on expiratory flow, so being able to blow as hard as you can through a peak flow meter. But it suggests that actually inhalation and inspiratory flow may also be impaired in the days leading up to an attack. And that's important because if we can put a sensor on people's puffers, they need to take their doses of medication anyway, so we can measure their inhalation as they take the medication. That could be an easily accessible digital marker as well of asthma attacks. It comes to heart rate. So here in the sample, you can see from an overseas study, they found in general that people with asthma had tended to have lower heart rates, and when it comes to post-exercise and heart rate recovery, which is what this shows, that they took longer and the change in heart rate recovery was smaller compared to the control group. And again, it's mirrored again in this other study, which looked at things like step count and sleep duration, and it looked at controlled and uncontrolled asthmatic and the healthy population, which is in red. And you can see across all parameters, step count in general is lower in people with asthma. Physical activity as well, and heart rate, you can see there's a change of heart rate. That heart rate seems to be higher in people with uncontrolled asthma compared to those who are controlled. And also sleep is also affected, and which is not surprising because of nocturnal cough in those who have controlled or uncontrolled asthma versus a healthy population. So we've been really focusing on these particular parameters, but again, day 0 is the day of the attack. You can see a reduction in step count, an increase in nighttime heart rate, and then a drop following an attack. And that all seems to coincide with drops in lung function and an increase in symptomology. Which brings us to the exciting DigiPredict solution. So I think where we're at is that what we want to do is use a smart watch and link to your phones to develop a risk score, and that risk score will continue to learn from your individual parameters, so that will be your personal risk score for your particular type of asthma. And this study will be the world first that's bringing together the biology, the physiology, and environmental factors. And we're trying to put this all together to look at how we can produce a personalised alert system. And unlike any other alert system, what you can see here, the attack risk is really personalised and is more accurate because we're drawing on multiple data sources. So this is an example of an example patient, day 0 being the date of the attack. You can see the heart rate variability might drop before the attack. So heart rate variability has been shown to correlate with inflammation. The lower your heart rate variability, the less healthy you are technically. So that's dropping before the attack. You can see sleep going down. You can see pollen going up potentially, the coughs going up, and the inhaler use also going up. So it's that picture that we're trying to capture with these digital markers. And I'm pleased to share, and this is hot off the press, this is data from our study so far, using the data we've collected so far from our patients. And we were really surprised as an investigator team at the accuracy and the performance of the smartwatch-only model and the poor performance of self-report. And this is really eye-opening because current clinical gold standard is we rely on things like the asthma control test and self-reported symptoms to predict attacks. And you can see it has really poor correlation in terms of being able to predict an attack. But surprisingly, using just the smartwatch parameters, you can see the RROC performance, the closer it is to 1, the better the performance. It's got really good performance just based on those parameters. We also did some really important engagement work with support from AMRF and CMDT and MedTech Consortium, and they found out through interviews with Samoan, Tongan, Pacifica families, Maori families, they said that they're really enthusiastic about the potential of this technology. They think that, you know, it's great that we can shut down the potential of an attack from happening. A 76-year-old kaumatua told us that they thought it would benefit mankind immensely, and that it was really important for whānau members, and they felt that the technology wouldn't be a barrier because they said it was something that could help Aija in our family. If their grandma was asthmatic, then everyone would help pitch in to help monitor the asthma and see how they could help their grandma. So this is a long journey. This is where we're at. It started, you know, in 2021 when we started using big data sets to really characterize the size of the problem for New Zealand. We then went out to communities to try and understand and explore the acceptability of this technology. Then that led to this key seminal study funded by AMRF, looking at identifying these novel digital markers of asthma exacerbations. It says 165, but actually this morning I think we're actually 173. And we think we'll get to the 200 because all 200 actually have booked in to see us by the end of August. So what we hope to do is build this prediction model and then bring it back to help people monitor asthma and provide alerts. So the next step to this is we're going to do a randomized controlled trial, which AMRF is also supporting, and then we hope to see how does this actually compare to standard care so we can actually implement it in routine care. And this is all just clippings like, you know, the smartwatch potential is great. It's been used already, especially for cardiac alert notifications. So potentially we can now expand it to respiratory and asthma. And I just want to say this has really been an enormous effort. The partnerships are worldwide. We've had support from so many people. And in particular, shout out to the team today here, some of them in the audience. We've had a lot of collaborators from clinical leaders, data science, Māori and Pacifica engagement, from primary care, such as National Hauora Coalition, Tend Health. And also really want to talk about my senior research fellowship. I looked back it's year 3 of my fellowship, and in just 3 years, this is what we've really achieved. We've had so many students that have been supported. You know, we've had 9 research assistants that have been part of this project, 2 research fellows, 5 PhD projects as part of this. We've managed to get some more grant funding to help with grow and conduct this study. For example, we were able to make Fitbits free and smartwatches free for people in the study. And we've also had so many other outputs and a lot of media and international engagement. So really big thank you to AMRF. So as we know, hopefully I've managed to convince you that, you know, struggling to breathe is not okay. And if you'd like to scan the QR code here, thanks to Jay, Dr. Jay Gon in the audience. He's our AI and our marketing lead, but he's helped develop the prototype of what this app might look like to envisage it. So if you scan here, you can have a look at what we think that score might look like in the years to come, maybe next year when we go to trial. So yes, just really want to thank you all, and I'd love the kōrero after and the discussions. So thank you very much for all your support.
So that was absolutely phenomenal, Amy, and everything that you've achieved in the last few years since we've supported you has just been incredible.
Thank you, sir.
And Amy was recently promoted to head of pharmacology. So another accolade to Amy. So, but we have got time for questions because Amy, beautiful with that.
Hi Amy, that was a great talk, thank you. And also kind of close to home because I know a few people in my family that have asthma. One question is, what is kind of the average age at which people are diagnosed with asthma? And is this something that could be used for younger children, or is it more kind of aimed at adults?
It's a great question. So the question was for the audience on the live stream. They wanted to know the average age of diagnosis for asthma and whether this technology could be used for people who were younger all the way to adulthood. So asthma, the incidence is actually, there are two peaks. It's often a childhood condition. So most asthma happens, around that kind of 5-year-old, younger kind of childhood period. But it does go all the way to around teenage years, and then often there is a dip or the growing out of asthma that you might have heard, but there is a second peak that happens around 40s, and often much more severe onset asthma or adult onset asthma that we often see. So it's technically bimodal, so there's two peaks. In terms of the technology, so the study we opened to 10-year-olds and above with no upper age limit. And so the oldest participant is 74 in our study, and the youngest are the 10-year-olds. And we've had such good feedback across all ages. The only reason for 10 is just that we wanted people who could have access to the technology and that were open to using the apps to log their symptoms. But we know children are very tech savvy these days, so I think we could definitely look at opening up to 7, 8, 9-year-olds, and we've had really good feedback, as I said, across all ages.
Thinking about the quality of air in Auckland, I understand the quality of air is not very good, and the number of asthma attacks is related to that. People think we've got a nice, clean environment, but actually it's quite polluted.
Yes, thank you for that comment. So the comment from the audience was around air pollution and the air quality in Auckland area or in New Zealand, and that often people think New Zealand air is clean, but it may not be as clean as it is. And that's absolutely right. There is data that we've got from Auckland Council which looks at PM 2.5 and PM 10, which are basically looking at the size of particulate matters. And we definitely know, like near highways and motorways, and there's a clear urban-rural difference in terms of the air pollution. And that has been shown overseas to be related to asthma attack data. We're just currently in the process of analysing that. But there is definitely the hypothesis of having worse asthma if you're living in a more polluted and urban area. But there's also the other new hypothesis around green space. So in a more urban area, there's worse pollution, but there's also less greenage, so less plants. And the less greenery there is, that seems to be also associated with both the development of asthma and worse asthma control.
Hi Amy, thank you for that beautiful presentation, it was fantastic. I'm just wondering, with the increase in vaping that's come into our society, what is that impact on your studies? Is that sort of taken in? Because I know that previously it was smoking, but that's kind of been, but the younger generation has just grasped onto vaping like nothing else.
Yes, that is one of our key baseline questionnaires. When they come to see us, we ask about their smoking and their vaping histories, and we do have a number of vapers as well. In terms of how does that affect it, the physiology, we haven't looked at vapors versus non-vapors, but that's definitely worth doing in terms of do their digital markers differ. But because our alert system is personalised to the individual, so it's basically relative to your baseline, how does your heart rate and your sleep and your step count change relative to what's normal for you, then it's applicable for whether they're vaping or not, or whether they stop or not, as the baseline will just adjust if they take on vaping or stop vaping. So then the system will have to relearn what might be normal, but what we're really focusing on is that change, so in terms of detecting abnormalities, so changes in these physiological measures. But definitely that is of concern, especially the young people coming to us who have a lot of vaping. And we did also, in a separate related study, take some breath samples from those who are vapers and non-vapers to try and understand what the differences are. So watch this space. There's a lot of data that we have to analyse and work through.
Do you also collect data about the quality of air indoors? Because a lot of the housing of low quality has mold and all other sorts of particles that would affect children, of course, at the start, but also older people. So are you looking at those markers as well?
So I believe the question was around indoor air quality.
Yep, correct.
Yeah, so just repeating it for the online audience. So the question was around, am I looking at indoor air quality, recognising that that is also related to asthma control, particularly in New Zealand with damp housing and things like that, humidity. So we did initially, when we conceptualised the study, think about whether we could put indoor sensors in people's homes to look at humidity and dampness, but then the technology burden was too high for people to be monitoring the indoor environment. So I guess in short, we're not looking specifically at the indoor air quality, unfortunately, but we do recognise the potential of like on-body sensors to monitor that.
So the smartwatches could not do that? They could not?
No, the current smartwatches can't detect indoor air quality or outdoor air quality for that matter. But maybe that suggestion we should feed back to Garmin and Apple. But maybe watch this space.
Please, everyone, if you'd like to thank Amy for her amazing presentation. Thank you. I think both the presentations tonight have, they've said so much in the presentations and said it in such great terms, in terms of lay terms and us being able to understand it, that the range of questions just haven't had to be asked. But I would like to invite both Tim and Amy back up here just so we can say a little thank you. Both Tim and Amy have received fellowships from Auckland Medical Research Foundation over the years, but these two are the reason we exist. We exist to support particularly the career pathways of researchers, and that's the reason we can have so many yeses to these really, really complicated questions that are being asked, and the years and years of work and passion that goes into it is absolutely extraordinary. So I'd just like you all to put your hands together to thank these two extraordinary researchers. Everybody online for joining us tonight, but thank you everybody too for coming in person to this third speaker series event, and thank you too for our 70th partners that are here tonight. And yeah, please keep on supporting Auckland Medical Research Foundation, because actually these are the people that we support it. So I wish you good night.